Alright guys, today we're looking at 11-8 and our topic here today is going to be the binomial theorem. And so what the binomial theorem does, it allows you to expand a binomial that's raised to a higher power without having to multiply out using the distributive property. Okay, so like for example, what we've got here is a little chart with x plus y, that binomial raised to different powers. All right, and so here's what we want to notice about this. The coefficients of the terms actually produce Pascal's triangle, the number in Pascal's triangle. And so for those of you who are not familiar with Pascal's triangle, to get the next number in the row, you take the previous two and add them together. In other words, you're always going to have 1 on the ends, but this middle term is going to be 1 plus 1. And this term is going to be 1 plus 2 makes 3. 3 plus 3 makes 6. 4 plus 6 makes 10, and so on. And that's how you get the next numbers in the triangle, is you add the previous two right above it. Okay? And it just so happens to turn out that when you raise a binomial to various powers, the coefficients of the terms actually yield the numbers in Pascal's triangle. And so we actually use that in order to get the binomial theorem, which actually helps you to multiply these out to expand it without having to multiply them out using the distributive property by hand. So like for example, once you take and raise this thing to the 7th power, then you would have to write this binomial out 7 times and then multiply it using the distributive property over and over and over to get this, which would probably take a sheet and a half of paper if you were just multiplying it out by hand. However, we can use the binomial theorem and the fact that these coefficients are the numbers in Pascal's triangle to actually multiply, or not multiply it out, but expand it out and write this expansion a lot more quickly and more efficiently than just multiplying it out by hand. All right, and so that's the usefulness of the theorem. And so another thing that you want to notice about this too is as you go down in higher powers, right, notice kind of the other pattern here. Okay, so what we do is we start with this term raised to the same power, this term raised to the 0, right? So it's y to the 0, which is 1. So x to the 4th, y to the 0. Then the first term, the x, drops in a power, and the second term, the y, increases by 1 power. So here we have x to the 4th, y to the 0th, x to the 3rd, y to the 1st, x to the 2nd, y to the 2nd, x to the 1st, y to the 3rd, and so on till we get to the end. Okay, so that's kind of the power for the binomial, or that's kind of the pattern, I should say, for the binomial expansion. The coefficients are the numbers in Pascal's triangles, and the powers of the terms increase and decrease in alternating order every term until you get to the other end. All right, so that's just kind of what I want you to see as far as the patterns are concerned. All right, so now let's see how we can actually use the binomial theorem. Okay. All right. So in the expansion of this binomial raised to some power, then that expression is equal to, and again, what they've done is they've written this out in generalities, the two patterns that I've just shown you. Okay, and this, of course, is, some of you may be familiar, is a combination, like N chooses R. How many different combinations can you get there? Well, it just so happens to turn out that those combinations produce the numbers in Pascal's triangle. So again, this is the general formula for the pattern of the coefficients in front of each term being the numbers in Pascal's triangle, and the powers of these terms alternating, just kind of like what I had showed you earlier, right? Now, for those of you who are not familiar with combination, here's what it's equal to. So a combination of N chooses R is equal to N factorial, which, remember, factorial means like 5 factorial is 5 times 4 times 3 times 2 times 1. So that combination is equal to N factorial over N minus R factorial times R factorial. Okay, and we'll get some practice at calculating that here in just a moment. And also, sometimes instead of writing it with the C notation, you'll see it written like this in parentheses, where this is the first number and this is how many are being chosen, right? So this is used a lot of times in place of the C notation for the combination, all right? And so again, this is kind of how you find the binomial coefficients. So the first thing that we need to make sure that we can do is we can calculate these combinations correctly, because it is a part of the binomial expansion in the binomial theorem. All right? So 8 chooses 2. What's the combination? In other words, of 8 things, how many combinations can I get when I pick 2 of those 8 things? All right? And so those of you who have studied probability or had some probability sections in previous math courses, you're probably familiar with how to find combinations. And so let's go based on the formula. It's n factorial. This is my n, so this would be 8 factorial over. And then we got n minus r, so 8 minus 2, which is 6 factorial, times 2 factorial. All right? Now, most calculators have a factorial button on them, but notice, 8 factorial is 8 times 7 times 6 times 5 all the way down to 1. This is 6 times 5 times 4 times 3 times 2 down to 1. Well, guess what? Everything from 6 times 5 times 4 is going to cancel out with this 6 factorial on the bottom. So really on the top, all you're left with is 8 times 7, because the rest of it is going to cancel out from the 6 factorial. Then on the bottom, I just have 2 times 1. All right, and if you go and you multiply that out, 8 times 7 divided by 2, 28. Okay? So 28 is the correct answer there. Let's do the next one. Here's the alternate notation that was denoted here that we've seen. All right. And so we want to go on this one. That would be 10 factorial over 10 minus 3 is 7 factorial times the r, which is 3 factorial. Again, everything from 7 down to 1 is going to cancel out. So on the top, I have 8 times 9, or 10 times 9 times 8 over 3 times 2 times 1. If you multiplied that out and divided by 6, you would get 120 here. And the last one, 7 chooses 0. And when we go and we look at that, that would be 7 factorial over 7 factorial times 0 factorial, which, by the way, is just 1. So that's 7 factorial divided by 7 factorial. That's just a 1. So with 7 objects, how many different combinations can you get by choosing 0? 1. You just don't pick any of them. All right? Now, like I said, your calculator has actually a combination calculator on it. The Desmos calculator does anyway, so let's look at that. And so to find it, if you go over to Functions, Stats, and the combination button is there under Stats. And so when you plug it in, like for example, if I wanted to do this first one again, you would put the 8 first. Okay, you put the n number first, then you would put 2, and then it'd give it to you. 28, which is what we got. If I change it over here to 10 and 3, okay, same idea, we get 120. And then once again, if I go 7 and 0, it's the same idea, we get 1. All right? And so those are the quickest way that you can get the combinations. All right, so now let's take one where we're actually going to be using the binomial theorem to expand the binomial. So what we want to do is we want to write the expansion of this, x plus 1 raised up to the third power. Okay, so now remember, as we're doing this, the first thing that you want to find is you want to find the binomial coefficients, right? The binomial coefficients. And remember, okay, we need to find the numbers here that are in front of each one of the coefficients. In other words, this number with the combination that we're looking for. All right, so here's the deal. Okay, and here's another thing I didn't point out earlier. If it's raised to the second power, you've got 3 terms. If it's raised to the third power, you've got 4 terms. Fourth power, 5 terms, and so on. So whatever power it's raised to, you're always going to have one more term than that in the expansion. Okay, so if it's raised to the third power, how many terms do I expect here? I would expect 4. And so here are the combination numbers I need to find. I need to find 3 chooses 0. I need to find 3 chooses 1. I need to find 3 chooses 2. And I need to find 3 chooses 3. All right, so I need to find all those different combinations because those are going to be the leading coefficient numbers in my expansion. All right. Now, you can plug that into your calculator or do it the long way by hand if you want. But really, the quickest and easiest way to get these 4 numbers is to look at Pascal's triangle for a binomial raised to the 3rd power. So I know these numbers are going to be 1, 3, 3, 1. So actually, you can save work by just go ahead and writing it in. 1, 3, 3, and 1. And then, of course, if you wanted to quickly verify a few of these or all of them, then you could. Okay, it wouldn't take very much work to come back in here to put it into the calculator to double check that 3 chooses 1 is 3. All right, so you can double check that and make sure. But remember, if it's raised to the 3rd power, then go here and see what the numbers in Pascal's triangle are. So what I'm saying is you can get those leading coefficients pretty easy just by looking at this chart for Pascal's triangle. Now, if you're asked for anything over the 7th power, then you're going to have to figure them out. Or look up Pascal's triangle on the internet to get the next row. Or get the next row yourself, or whatever the case may be. But if it's raised up to the 15th power, then that may get a little bit cumbersome. And as a matter of fact, I'm going to make a point here in just a moment about raising them up to actually higher powers. Okay? Let's see. So here's the next thing that we want to look at. All right? So from here now, what I'm going to have to do is I have my leading coefficients. The next thing I'm going to do is I'm going to use the rest of this formula now to write in these terms with the alternating powers. Right? Writing these terms with the alternating powers. So the first leading coefficient is 1. And so I'll go ahead and write in my 1. And so remember, the first term is x. And don't forget that x is going to be raised up to the 3rd power. The 1 is going to be raised up to the 0 power. Right? So I'm not even going to write that. That's just the 1. Then plus, what's my next leading coefficient? 3. The x will now drop by 1 power. And the 1 will now increase by 1 power. So that would be 1 to the 1st power, or just 1. Plus, my next coefficient is 3. My x drops by 1 power, so that would just be x to the 1st power. But my 1 will increase now to the 2nd power. So notice that the powers of each one of the 2 terms is alternating. One's going up by 1, one's going down by 1. So it is kind of symmetrical like that. Then we have one more term. The leading coefficient is 1. My x is now to the 0 power, so I don't even have to write it. But my 1 raises up to the 3rd power. All right, so some things to notice. Okay, my leading coefficients go here in front. My 2 terms, okay, the first one starts at this power. The second one starts at 0 power, and then every term they alternate. One drops by a power, and then the other one raises by a power until you get to the other end where the 1 is now to the 3rd power and the x is now to the 0 power. All right, so that's how you use the binomial theorem to write in the terms of the expansion without having to multiply it out 3 times. And from here, it's just a matter of simplification. 1 times x to the 3rd is x to the 3rd plus 3x squared plus 3x plus 1. So that is the correct expansion. Okay? All right, let's try another one then. Let's say I wanted to expand this one. So x minus 2y raised to the 4th power. All right? So let's take a look at that. So again, we need all of our leading coefficients. So that'd be 4c to the 0, or the combination of 4 chooses 0. We need 4c1, 4c2, 4c3, 4 chooses 4. All right? So those are the numbers that we need. Once again, I can go to the fourth row in Pascal's triangle and look at it here, and the numbers are 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. And like I say, once again, if you want to do them by hand or test one or two of those, then you can. So it'll be 4 chooses 2 is indeed 6, just to verify, like this middle term, that we've done it correctly. And so, like I say, as long as it's under the 7th power that you're asked to raise it up to, you can just get those leading coefficients from this Pascal's triangle. And even if it's higher, I'm sure you can very quickly on the internet find the 15th row of Pascal's triangle and so on. All right? So now, let's go ahead and plug them in. So my first number is going to be 1, and that's going to be 1 times x raised up to the 4th power, and then times 2y, remember it's this whole term, 2y raised up to the 0 power, don't have to write it, plus the next one is going to be 4 times x to the 3rd power, and then times negative 2y to the 1st power. So we'll just alternate powers from here on out. One will rise, one will drop. Plus, my next term is 6. This is going to be now x squared, and it's going to be negative 2y squared. All right. Plus, all right, so we're just continuing to put the terms down here. So that'd be 4. And this would be just x to the 1st power, which is just x, but it's going to be negative 2y raised to the 3rd power, plus 1 open. The x now is to the 0 power. Don't even have to write it, but I can write negative 2y raised up to the 4th power. Okay? So now these are all my terms using the binomial theorem. And once again, make sure you understand the pattern. These leading coefficients are the numbers in Pascal's triangle, these combinations. And then again, my two terms alternating with power, x starting with the 4th, negative 2y starting with the 0, and then the x goes down by 1, the negative 2y goes up by 1 power every time until we get all 5 of our terms. Okay, so remember, if it's raised to the 4th power, then I have 5 terms total. So now it's just a matter of simplifying, and then we've got it. So this would be x to the 4th. That's going to be a minus 2 times 4 is 8, x to the 3rd y. Then we're going to have a plus, because this would be negative 2 squared. So negative 2 times negative 2 is positive 4 times 6 would be plus 24. So make sure you get your signs correct here. Don't make a sign mistake. X squared, y squared. Then we're going to have negative 2 to the 3rd power. Negative 2, negative 2, negative 2 is negative 8. Negative 8 times 4 is negative 32. And then that'd be x, y to the 3rd. Then we're going to have plus. This will be a plus. And so negative 2 to the 4th power is a positive 16, and it's just times 1, so we'll have 16 y to the 4th. Okay? And so, as you can kind of see here, really in 3 steps, we can multiply out this entire binomial, right? To whereas if we had done it by hand, we would have had to have written, or if not by hand, but if we had multiplied it out with the distributive property, we would have had to have written x minus 2y times itself 4 times and done all of those multiplications, all of those distributive properties, which would have taken us much longer. And of course, you know, if this was to the 6th or to the 8th power, then this really saves us a lot of time. All right? Now, let me kind of speak to how it's going to work if they ask you for like a really high power. Like if they had asked you to raise this up to the 10th power or the 15th power. Typically, when it's raised up to a higher power like that, they won't ask you to write out the entire expansion, because that would be 15 terms, a string of 15 terms that you would have to write out. Okay, so typically with higher powers, they would just ask you, okay, what is the 8th term? of this expansion, or what is the fourth term or the ninth term of this expansion. All right? So what you can do is you can hone in or zero in on one of these terms instead of having to write out the entire expansion. All right? And so that's what we're going to be focused on now on the next set of problems. Okay, so there's a formula. In other words, you would just pick out one of these terms. And here's kind of the general formula to just pick out one of the terms instead of having to write out all of the terms. And so here is the formula for the expansion of the r plus 1th term. R plus 1th term, because this formula is here in terms of r, right? It's in terms of r, the r plus 1th term, the r plus 1th term. And here it is. It's n chooses r, right, in a combination. That's the coefficient in front. And then x to the n minus r power times y to the r power. Okay, so this would be the correct leading coefficient for whatever that term is you're looking for. And then this would be the correct powers for the two terms in that particular term that you're looking for. So let's use this formula so that you can kind of see what these letters stand for and what to plug in for them in one that we've just done. So now I'm going to say, all right, so for this expansion, for this binomial, x minus 2y raised to the 4th, the one we just did, I want you to find the second term. I want you to find the second term. Well, we already know that this should be the second term. Okay, but I'm going to show you how to do it with this formula so that we can do some problems with higher powers coming up. All right, so I'm looking for the second term. All right, I'm looking for the second term. All right, so first of all, this n right here, when you start to plug in, that n is going to be whatever power you're raising the binomial to. So this is going to be 4c, right? So this is going to be 4c. The n is always the power, right? N is the power here. All right, so that's going to be 4c. Now the r, okay, remember the r plus 1th term is what this formula is for, right? So if I'm looking for the second term, the r is going to be whatever this term is minus 1, because this is the r plus 1th term, right? So if the term is 2, then r's got to be 1. 1 plus 1 makes 2. So whatever the term number is that you're looking for, you subtract 1 from that number and you have your r. So 2 minus 1 makes my r 1 here. Okay? So r would be 1 here. So remember, the n is the power. Okay? The r is whatever term you're looking for minus 1. And once you have the n and the r, you have everything to plug in for the rest of the parts that you need. So for example, for the rest of this would be x. Okay? This would be x to the what? To the n minus r. So that would be 4 minus 1, which means 3. So that's x to the 3rd power. Then we have y raised up to the r power. Well, what's the r power? R power is the 1st power. So like I say, these two are the main numbers that you're trying to get. Once you get these two numbers, then you can get your powers correct. Okay, you can get your powers correct there. So like I say, the n is the power that you're raising it to. The r is going to be whatever term they're asking you for minus 1. Okay? And so, let's see. I didn't plug this y in right, by the way. Because remember, that second number, that second term's not y, it's negative 2. Y. So I need to actually put that in a set of parentheses and go negative 2y. And then, of course, it's raised to the 1st power. I didn't really have to write that if I didn't want to. And so now all we have to do is figure out what the combination of 4 chooses 1 is. And so combination of 4 chooses 1. Okay, we already found it in the previous problem. It is 4. You can double check it again if you need to. So now this becomes 4x to the 3rd times negative 2y. Okay? And one more step would yield negative 8x to the 3rd y. And notice that is indeed the second term. That's the same answer that we got when we did it with the full expansion. All right? And so that's how you would use this formula to find a certain term instead of finding the entire expansion. And like I say, a lot of times they will ask you to use this when the power is really high. So instead of writing out 8 or 10 full terms, they might just say, okay, what's the 6th term or what's the 4th term? and then that's where you would use this formula. Okay? So like for example in the next problem, I have this binomial raised to the 5th power. I'm looking for the third term in this expansion. What would the third term of this expansion be? All right, well, I'm ready to use my formula. N is 5 because it's raised to the 5th power. So that would be 5 chooses N. Remember, R is this number, the term number minus 1. So 3 minus 1 is 2. All right. Now, I'm going to be raising X here because X is this number. It's going to be X to the N minus R power. So if I want the correct power for that first term, subtract these two numbers. 5 minus 2 makes 3. My second term is negative 6y. And then I need to raise that to the R power, which is 2. And so now it's just a matter, once I've got it plugged in correctly, it's just a matter of simplification. The combination of 5 chooses 2. I need to figure out what that is. We can do that very quickly with Desmos. And so I want the combination of 5 chooses 2, which I can see there very quickly is 10. So that number now becomes 10. And it's going to be 10x to the 3rd times negative 6y squared. And so then I can come up with my answer. Negative 6 squared is positive 36 times 10 is 360. All right. And let's see what else. X to the 3rd y squared. So this would be the third term in this expansion. Make sense? This would be term number 3. All right? And so that's how it works. So like I say, when the powers are big, typically they may ask you for just a certain term as opposed to expanding the entire thing. One more problem to look at. And so that'll be one here like this. So again, I need to know that my N is going to be 9. So that would be 9. Let's write that a little better. So that would be 9 chooses. And again, remember my R is going to be 1 less than the term number they're asking me for. They're asking me for the 8th term. So my R is going to be 7. 1 less. Always 1 less. Okay, so what's my first term here in the binomial? It's 4x. And so remember that first term is going to be raised to the N minus R power. So what's 9 minus 7 going to be? 9 minus 7 is 2. All right, what's my next term? 3y. All right, my next term is 3y. Okay? And so 3y is going to be raised up to the R power, which in this case is 7. So 3y needs to raise up to the 7th power. Okay? And so I need to figure out what the combination of 9 chooses 7 is first. Let's put that one in there. 9 chooses 7 is 36. Okay, so 9 chooses 7, 36. So I'll put my 36 here. All right. Then I can go ahead and square this out, which would be 16x squared. All right, 16x squared. Then I need to go ahead and raise this to the 7th power. So I need to figure out what, let's see. I need to figure out what 3 raised up to the 7th power is. It looks like it is 2187. So that would be 2187 y to the 7th power. Okay, y to the 7th power. So now it's just a matter of multiplying all those numbers together. And so when you do, you should get 1, 2, 5, 9, 7, 1, 2. All right. And so that's over a million x squared y to the 7th. All right. So this would be the 8th term in this expansion. Okay, so like I say, if you were to get the entire expansion, it would take a while. But like I say, when the numbers here, the powers are really high, typically they will just ask you for one term, a certain term, and then of course that's where this formula comes in, and then you can come up with this, the 8th term in this particular expansion. All right, so there you go. Your quiz is waiting for you now on Canvas, and then we're done.